For those Colligan, we spend the written homework 5 for heat and mass transfer. For the first problem, we have a bunch of steel balls that are cooling down after being in a furnace, and we want to determine the heat transfer from 2,500 of these balls. In order to do this, we need to determine if lumped analysis applies with finding the Biot number. In this case, the Biot number is 0.00185, which is less than 0.1, therefore lumped analysis applies. From there, we can use the lumped analysis formula to determine the time that it takes for the ball to cool down, and from there we need to calculate the B, which is shown here. And then once we have that, we can determine the time, which is about 2.8 minutes, and then we can determine the mass of the ball, and from there we can take the number of balls times the heat transfer rate of the balls, and that will determine the heat transfer rate total of all 2,500 balls, which is about 542.5 watts. Next, it wants us to determine the you determine the one-dimensional transient temperature distribution on the ground as this air is passing over it. And in order to do this, we first set up the full equation. However, we know the second term is going to go to 0 since the error function will go to 0 since the inside of the error function is going to tend towards something that's greater than 4. Therefore, this whole second term is going to go to 0. And then we're left with that the excess temperature is equal to the error function of x over root alpha t, and then from there all we have to do is solve for the temperature at position and time, and we're given the time and the depth, and from there we can just evaluate to find the temperature, and that's shown right here at the top in this Excel table where I evaluated it. And then for the next problem, we have an ice cube. I want you to find where the first drop of water will form, and from there we need to assume that the walls can be treated as two infinite plane walls. One of them is 4 centimeters thick, and the other one is 12 centimeters thick. And then from there, we can find the Biot numbers for each, and then the lambdas, and then the A values for the first term of each of those walls. And then once we have those two, we can use the one-term approximation in order to determine the two-dimensional one-term approximation in order to determine the time it will take for this temperature change to occur. In this case, the final temperature is 0 because that's when the ice will start to melt. And from there, you have to solve for t, which is this giant equation right here, and that will give you the t is about 19.5 hours for the first drop to form. The last problem, it's a semi-infinite medium approximation problem, but this one's for concentration of two solids. And basically, you just need to assume the concentration initially is 1, and then at a certain depth, it turns into 0.4. So then you have the pretty much the excess concentration equals the error function of x root 2 dt. And then from there, all you have to do is solve that 0.6, that's equal to excess concentration equal to the error function, and then what's inside that. And then from there, you need to solve what would be inside the error function to equal 0.6. And I use the Excel solver tool to find that, and its insides would be 0.378. So that means 0.3708 will be equal to the x over root 4 dt. And then from there, you can just simply evaluate the two times they give you, which is the first one is 1 hour and the second one is 10 hours. And from there, that'll give you the depth that the concentration will be 40%. And it's obviously going to be a farther down depth for the larger time. Thank you.